Welcome back to HANA Basics for Developers. In this next unit on Node.js, let's revisit the topic of JavaScript basic language features. Now, you might remember that we did this earlier with XSJS, and of course, the fundamentals of JavaScript are the same, whether you're working in XSJS or Node.js. But some of you may have skipped over the XSJS section thinking, well, okay, that's older stuff. I never did any of that, so let me just start in with Node fresh. And that's perfectly fine. Therefore, I want to make sure that we cover some of the basics again. I'll also show you, I'll point out some of the places where there are obvious differences, not so much in the syntax of JavaScript, but just how that basic JavaScript functionalities may be utilized from the two different environments. Plus, I added a couple of things to the basics section, JavaScript language features that are maybe a little bit more specific to the Node.js environment. Okay, so let's switch over to the system. And just remember, we did do a very similar video earlier in our XSJS section where we created this inside our XSJS. We had our JavaScript basics, and then we just created little XSJS services for the major different concepts here. Like, we started with strings. We just created a function that's called by the service that demonstrates different features that you could do with strings. Here we're building up a body variable and then outputting that in the $response object. So I think it'd also be interesting to see the comparison here when we look at how we're going to do this in Node.js. Well, obviously, we are in a different environment. We're still going to have a RESTful service, but we're going to create a route handler just like we have with the other parts of our Node.js service. So we're going to come here to the same SRV folder and the index.js inside of our router. And we'll come here and we'll add another route handler. So app use Node JavaScript basics. And then we'll go to a file fire in our routes that we're going to call JavaScript basics. There we go. There's our route handler. And we want to do, basically we of course want to add another route here called JavaScript basics. Let me go ahead and put that here in my project. And actually, I have the complete source code already prepared since we just want to look at different source code examples here. I don't want to do a whole lot of typing. Go ahead and bring this over, and then we can start talking about it. Now, the obvious difference here is we're not going to create separate files for the different examples. We could have. I certainly could have just created in my index.js a bunch of different route handlers that went to different files. I decided, even though this file is a little large, I'll keep all the basics together in one file, just so you can go and find them in one place. Yeah, just a design decision on how I wanted to lay this out educationally. But one of the major differences here, we obviously have a function where we've got the $request response object. We're not really taking request in on most of these examples. We're really just using the $response and building up the string and putting it in the body. Essentially the same thing here. We've got separate event handlers for the different requests to subparts of the URL. So it's going to be like /JavaScript basics /strings using express, telling you what verb we want, the get. We've got the request response object, not in the $, but being passed into our event handler. But otherwise, it's the same sort of thing. We build up the body variable, and then we take the response object. We set the type of the body, the HTTP response code, 200, good, and then set the body into the response. So, just helping you, if you did do the XSJS chapter, I think that's kind of nice to see the flow differences between the two environments, but how essentially what we do is pretty much the same in both environments. Let's go ahead and run this change to pick up our new JavaScript Basics service. And then, like we did in the XSJS unit, I can pull them up side by side and run through the code and the execution side, so you can see them together. So go ahead and bring that up. I'll put it. If I can get it to snap here. There we are. And bring that up full screen. So let's navigate to our node. And our first test is strings. Actually, you might be interested. What I did here is this. If you just go to JavaScript Basics, I just created a little HTML page in the response object directly. So I didn't create a web page. Not serving it statically. Just parsing or just concatenating together into a string with a little bit of HTML formatting. Just a basic kind of table of contents here that goes to the different sub URLs. But let's start here with strings, just like we did earlier. And for the most part, I took the same examples and simply rewrote them. I mean, you can see that here between strings, XSJS, and JavaScript Basics, the Node.js version of the string. It is the same logic. It is the same syntax. Nothing has fundamentally changed. So I think that's also nice to show you how moving from XSJS to Node.js, when you're talking about the basics of the syntax, even the asynchronous nature of Node.js doesn't really come into play here, because all we're doing is concatenating and some very basic commands. They aren't asynchronous by nature. So our logic is pretty much straight transfer over. So now, from this point forward, let's kind of concentrate just on the JavaScript syntax. Once again, we declare a variable. JavaScript is untyped, so I don't tell it that it's a string. But the fact that I initialize it with this empty quote, that is a string, and then it starts to take on the properties of a string from that point forward, and that's where we get these extra commands: the dot slice, the dot to upper, the dot to lower. They are functions that are type specific. So this variable sort of transmutes which functions are available based upon what data type it currently has in it. This is one of the fundamental concepts of JavaScript, the loosely typed, to the idea of adding functions to a variable based upon the type. In other programming languages, including ABAP, these would be keywords that were part of the syntax itself, and that technically you could take that keyword and apply it to any variable. Of course, if the data type of that variable didn't work, you would get an error. You'd get a syntax error, because the types would be statically checked at compile time, build time, whatever it is based upon the environment. JavaScript, because it's interpretive, wouldn't necessarily catch that. We don't really have a compile time. That's why we have client-side linters, client-side checks that will look at those kinds of things. For instance, if I would take body and I would initialize it here with a number, maybe I would get even in that case, I don't really get too many checks, because that would probably transform it to a string there. Maybe a little bit later we'll see if we can't break some things, but it changes the way you think about programming. Sometimes you don't catch problems until execution time. It makes your testing a bit more important. Some people like the untyped nature, the freedom that it gives you. Some people don't like it because of the exact same reasons that freedom comes with responsibility, and people don't like to find errors at runtime. You like to catch them at a compile time, an activation time, or something like that. There's pros and cons to each environment. There's no doubt that that gives you quite a bit of flexibility. I personally like the fact that the type specific functions are part of the data object themselves. I think it helps with the readability of the language, but sometimes can be tricky, finding errors. So what we see here, some of the common examples. We can get we can of course get the length of the string. It also is a built-in attribute of the variable, so just dot length, and because that's should come back as an integer, we'll convert that to string so we can put it so we can concatenate it into our output string. If we want to get the last character in a string, you can always slice off characters, but you can use negative indexes. So we're maybe used to using a command like slice to take the first however many characters off of a string, but if you use a negative index, then it's going to start from the back of the string and then work towards the front. That's a rather elegant solution, not needing two different commands to do front or back of string operations, just using positive and negative offsets there. If you want to convert to uppercase, convert to lowercase, I mean, I think those are pretty straightforward. To do a search inside of a string, I kind of like this, the fact that we don't need a separate regular expression command or a separate search command. It is just built into the variable as well. Same thing with the replace, so search, find, replace characters inside of a string. Pretty easy to use built-in functions on the variable itself. Okay, so we see the output there that matches up. Now let's talk about date objects. So let me change my output here to dates. Similar approach here. Obviously, we take on the data type based upon what's put in it. Here, I'm going to declare a variable of now, and I'm going to say equals new and a function. Calling a function, built-in function for date, and what this is going to do is not only initialize that variable as a date variable, but pass in the current timestamp into it. And that's one thing you'll notice maybe compared to other development environments, particularly the ABAP development environment. In ABAP, we have a date data type, we have a time data type, and we have a timestamp. And actually, coming from ABAP, the old date and time are actually character data types. ABAP has something called a numeric character, where it's a character data type that will contain only numbers, but it allowed us to do things like just treat it like a string, and we used to extract like the year or the month just by taking the subset and the offset, because we knew the internal format as it was stored. And that was good in the days when ABAP needed to be independent of maybe the underlying infrastructure that didn't support, going way back, maybe didn't support 4-digit years. That was actually the workaround to avoid Y2K problems way before the year 2000, because ABAP stored it not as a OS specific or database specific date format. We were just storing it as a string. We could extend and go beyond the limits of the OS or the database. So historical reasons that being. But that means that if you come to an environment like JavaScript, where we have just sort of this date object that is both can be both date, time, or timestamp, it might feel a little unusual at first, but it's actually pretty powerful and rather elegant. What we see here is the same sort of thing, built-in functions for conversions. I can take that timestamp, convert it to UTC. You see that when I output it in a string, it does nice formatting on it. That's obviously not the internal format as it's being stored, but just by putting it into a string here, I'm getting Monday. It's putting the month on there. It's doing all this nice formatting for me. I'm not having to do it. I convert it to UTC, shifting it to Greenwich Mean Time there from my local time zone, Eastern time zone. So you see nice formatting. I can say to local date string, to local time string. It's going to output in my format based upon my locale here. So the locale is being passed in from the web browser and being brought in automatically on the server side here. So I don't have to worry. There's no user settings that have to go be set up for this. This is coming from the web browser, actually, in this case. I can convert to other specific formats. Sometimes when you are doing an interface, the foreign system expects a certain format, so ISIS strings, JSON strings, you see those are actually the same thing, but two different formats. If I want to extract out just parts, would not do a splice. I would not assume the internal format of the data storage. You should use the built-in functions. Get full year, let's see, it's 4-digit year, get month, get day, get date. What we see here is the month 0, day 1. So Monday is day 1. Sunday would be day 0. Month January, 0. It's good that we point this out because we might expect January to be 1 because that's how we count it. Like when we write it in, like in output format, the 1 here in 1/21/2019 is January. But when we get the when we say get month, it is a 0-based index. So that requires sometimes some conversion if we then want to output to that to the user to take 0 and display it as 1, because I think most humans expect January to be the first month, 1, but this is all as you've learned, hopefully, JavaScript is mostly 0-based index, so it doesn't start with 1, starts with 0, so that's why we see that. Same thing here with the day of the week, day of the month. That's a little simpler. We can get the Linux time, number of milliseconds since midnight, January 1st, 1970. More commonly known as Linux time. So that's what happens when you do the get time. More specifically, what we probably want is hours, minutes, seconds. So we can pull those out individually here as well. And what do we see here? We can do math on it. We can say get date plus 30 would add 30 days. It's going to do all the calculations, crossover months, leap year, all that complex stuff. You don't have to worry about doing that. It's built into the function. It's very intelligent. So as you see here, we can just add 30 days, and then we're outputting that. So February 20th, and then add 30 more days to that, and we're moving out to March. And you see here, didn't just jump. So 21st jumped to 20th, 20th jumped to 23rd. We're taking into account the number of days in the month correctly. I didn't have to build any logic in for that. And kind of going back here where we did the output to locale string, to locale date string, time string, use my locale from the web browser, but we can force formats, international formats, whatever we want. We can force in the locale. So for instance here, I can use the US format or the German format. So these are built-in functions, not exactly built-in functions. What we do is we build a date type here, and then we use the built-in function of format off of that type. So little different than maybe some of the other built-in functions that are part of the data type. All right, let's look at arrays. Single array. So what we have here is we build an array of colors: red, green, blue. We build a second array: black, white, orange, purple, and we want to work with this array. An array is once again, if you're coming from the ABAP world, this is like kind of like a structure, not exactly. I mean, because you're going to see here that we're going to loop over it, kind of like an internal table, but an internal table that maybe you could think of it as having just one column, a single set of values, one record for each. But we can also treat it as not exactly like that. So it's kind of its own little thing. I can't give you kind of an exact equivalent in the ABAP language because it doesn't really have this exact concept. But what we can do here is we can take toString and output the entire array for us, all the records at once. We're not having to loop over it. We can access individual elements by its index. It is 0-based as well. So if we say color 0, we get just the first one, which is red. We can get the number of elements in an array using the length built-in variable there. We can also get it by name. and actually here this one, like before, not technically right. If I just do index of blue, I get a -1. -1 means not found. So that's important to know. That's why I have this incorrect one in here actually, because we're taking our HTML formatting here, so it looks all nice. We would actually have to search for this entire string here, the font color. You know, JavaScript doesn't know that that's HTML and this is actually our output value. It's just the array is the entire value there. So if we wanted to find blue, we'd actually have to search for this whole thing. We can iterate over the elements one at a time using a loop. So using the standard JavaScript concept for looping over things. We'll see this later. It works for arrays. It works for JSON, because JSON is really just an array of objects. So we just do a for, and we declare a variable to basically hold our counter for the length that is the entire array. We don't actually have to say length. This is a simplified syntax that came into JavaScript, I don't know, a couple years ago. We don't have to go get the length and do the var I and increment it to the like I plus plus. You know, you see that some places. That's actually the older format. This is tighter, neater syntax, easier to read as well. But then we're just able to output them one at a time. You can perform a concatenate on two arrays, and it will just combine the two arrays together. So concatenate is not just for strings, can be used on other object types as well. We can sort the array. Ascending is the sort command. Reverse sort using the reverse command. So built-in functions once again based upon the data type. Same thing here with pop, shift to take the last element off, take the first element off. We can use the slice command and take out specific portions, giving it a start and end index here. You see adding multiple elements at a specific position. We're able to use the slice command to put things in as well. If we want to put something on the beginning, we can use an unshift command. So just making you aware of the various manipulation commands there. Now, JSON, JSON's pretty important, as we've seen already. It's the main way that we return data coming out of the database interface. JSON, JavaScript object notation, although it's not specific to the JavaScript language. There's many other programming languages and environments that can process JSON. Java, C++, even ABAP can take JSON and using a kernel function, convert it to an internal table. And if we're drawing comparisons to the ABAP world, JSON is very much like the ABAP internal table in both its usage and use case. So what we see here is we are just selecting from the database, and our results come back as JSON. And this is very common. We can just take JSON and we can stringify it. So this is a language command. So this isn't built in on the data type, but we say JSON, a built-in library in the JavaScript environment, and then we say stringify, take the JSON, turn it into a string representation, so we can output it in the response object. But you also see here we're able to loop over it, and this is one of the differences between JSON and say ABAP internal tables. I can just create columns on the fly here. This discount amount did not come from the database. It was not part of the original JSON object. As I'm looping over the object, I'm just adding this discount column to it. And all your columns don't have to match. I could technically just add that to some of the records. I could have an if check around this. So your structure is variable. It's not fixed for every record. And that is part of the reason why, as you see here in the output and even the internal representation, the column headers, if you will, the name of each attribute in each record in the JSON is repeated. And you might look at that and go, well, that seems inefficient. That seems redundant to just repeat purchase order ID over and over again. But you can imagine, because as we said, it doesn't have to be in every record. And that's part of the power and flexibility of JSON, is the fact that every record doesn't have to match the same structure. Next, we have objects in JavaScript. So JavaScript objects, it's kind of this weird thing. It was pre a time before we had true object-oriented classes in JavaScript. It was kind of like it's not object-oriented. You can get close to object-oriented concepts. You can kind of have a constructor on an object. Now it's, if I were really coding like this today, and I wanted to have multiple attributes and have a function as part of my object, I would personally go ahead and use a class. We'll see the class here in a minute, and take on true object-oriented constructs with inheritance, public, private, polymorphism, all the things you expect. I would not try to treat the JavaScript object as a class, as we did here in this example. We tried to create a class constructor using a built-in function. It does work, but it's kind of not a very elegant approach. Now we have a better solution. But technically, all these other data types that we've been looking at, they are objects. Even JSON, it is an object, and it's an object of an array of elements. So there are certain aspects of JavaScript, like the ability that we can iterate over even a character variable, because it's basically an array of individual characters. That's part of really kind of the power of JavaScript, the fact that every data type is kind of an object. That's how we're able to attach functions dynamically to the data, the variable as it takes on its data type. That's all due to the object nature of JavaScript at its low level. But what I would, as I said, if you were really, using JSON, of course, using the built-in variables, if we've seen it makes sense. You're actually tapping into the object nature of JavaScript. But if you want to do object-oriented and really want to do the kinds of things where you have a constructor and things like that, then use the true class functionality. We have a new keyword, class, to declare a special type of variable that is a class, and it has built-in functionality like constructors. Here we have a function that is our constructor. It does have, I can create public and private functions inside of here. And there is inheritance and things like that. We'll look more at object-oriented JavaScript later. I'm going to do a dedicated video on that. So I'm not going to go into a great amount of detail right now, because this was a rather simplistic example. But you see here I even have another class here, a factory class, where I create a static method, and I'm using the factory construct to create my instance of my main class. So you can take all these really advanced object-oriented concepts and utilize them here. We've already talked about promises and async in earlier videos, so I'm not going to go into those details here. They're obviously an important part of the asynchronous nature of asynchronous non-blocking I/O aspects of JavaScript. Some of the other new things that came into JavaScript with ES6, ECMA scripting 6, we can now have constants. Pretty much like you would expect, you can declare a constant, and unlike a variable, we can initialize it with a value, but here, this fixed value, if I try to increment it, then it's going to throw an error, which I can catch and output. So I'll just show you what happens here. Constants. So what you see here, I initialize it to the value of 10 and 11. I try to increment that. Nope. Assignment to constant variable. Can't change the value. So before we had variables, we could pseudo try to create them as constants, maybe by wrapping a function around them or something like that. But now we have dedicated language constants. Okay. Block scope. What we have here, let me run the example. Block scoped. So now we can have variables that have a scope within the block that they're in. So if you declare a var, that is global, but we have the let command, and here we're saying output is we're declaring as let. We have a function foo that always returns 1. So in the outer, it's going to return the value of 1. But when we're inside this inner function, we basically redeclare foo. And it's saying no inner declarations because it can lead to inconsistent results. It's harder to catch, but it's possible. I want to demonstrate that it's possible here. And here inside the inner results, foo returns 2. So I can basically have a function that has a different scope, same name but a different scope, a different implementation based upon what level of scope that it's in. So inside this if statement, we redefine it in essence. We can have parameter defaults. Now, those of you that come from the ABAP world, you probably go, well, yeah, I would hope so. This is kind of a nice feature, certainly something that that many other languages have in the form of whether it's like method defaults, function defaults, call defaults, whatever. Basically, we have a function. And now we can declare a variable, and if somebody doesn't pass in a value, it will default. For instance, here if we just do math 5, we only pass in one variable. The other variables will fill in with their default values, as you see here, 27. And if I supply specific values, then they override the defaults, as you would expect. We can have multiple parameters as well. So if you have a really variable function and you don't know how many parameters you want to allow, this is actually used really commonly in JavaScript. This used to be rather difficult to deal with, the variable number of parameters. But now we can declare this p with ... in front of it. Basically means create an array of all the other variables that might be passed in to this function, and we can get the total number of parameters here. So what you see is we're passing in 1 and 1 to A and B, then I pass in stuff, more stuff, 8, last parameter. So 4 additional parameters are being passed in here, and I'm just getting the length here, but in reality I could loop over that array, get them one at a time, introspect them. This one is kind of interesting. We can actually use Unicode characters to declare variables now, the variable name. So I actually declared a variable here as a foreign language character. Kind of interesting. I don't know. I mean, unless you speak that other language, it doesn't necessarily make for more readable code. But if you want to code in a foreign language, a different character set than base character set, the Latin one, then it is possible to do now. The number and currency format, we saw this earlier with the dates. We can force particular output formatting for date and time. We saw that example with the dates, but you can also do this with number formats. So we'll take a look at that. So the position of the commas and the decimal points, obviously different in different regions of the world. We can force that in and output and override the user settings from the browser. We can do the same thing here with the currency format. So what we see here, and this is going to give you your actual currency code as well as the specific formatting based upon the region as well. So I think that's a really powerful addition. These are things that in the enterprise world we need a lot and we really expect to have. So I hope you've enjoyed this look back at JavaScript basics. I know we hit on other topics first. It's always hard to know what order. We did some promises and obviously database connectivity first. It's important to get some of the basics of the JavaScript language down if you don't already have them. And this now prepares us to move on to a few more complicated and more specific topics in the Node.js environment as well.